Hey guys, it's Miss Melder again. Welcome again to my home. I'm so glad that you're here, and I'm hoping that this video tutorial will be a way just to help guide you as you complete your assignments today. I'm going to try and keep things short and sweet. We've got 2 assignments this week, and what we're going to be looking at this week is how to identify proportional relationships, both from graphs and equations. And that's exactly what this IXL practice is going to do for us today. And so just a couple of things. It's been a while since we've talked about proportional relationships. And one of the things we have to remember is that when we are given a set of data, whether it's a table or a ratio, a set of ratios, what we can do is we can compare those y values, divide them by the x values, and we can see, does this table or set of data have a constant rate? And if so, that means we have a proportional relationship. If those rates aren't the same, then no, it's not proportional. And so the way we identify that in a graph is by 2 characteristics. If a set of data or a graph is proportional, number 1, it has to be a straight line. It either has to be increasing at a constant rate or decreasing at a constant rate. So we're looking at that straight line effect, okay? There also has to be, not only does it have to be a straight line, number 2, it has to pass through the origin. That is the point 0, 0. And so when we look at this first example here, it says select the graphs, okay, that show a proportional relationship between x and y. All right, so here we see our x-axis and our y-axis labeled for us. Okay, and so it's talking about this red line here in both of our graphs. So number 1, we should be able to see that both of these graphs have straight lines. Check. Number 2, do both of these pass through the origin? And so if we look here at the point 0, 0, where the x and the y-axis meet, this point right here, guys, so I'm circling it on my screen. Hopefully you're being able to watch that. Then yeah, they both pass through the origin. They're both proportional, so we need to make sure to select both, hit submit. It's slow. Come on, there it is. Wonderful, it says. Okay, so now we see that we have 2 graphs that originate from the origin. They pass through, but then there's this issue with this first graph. Guys, that's not a straight line, that's a curve. It will not be proportional. So I'm only going to select that second option. Terrific. All right, let's talk about equations. It's been a while again since we've talked about proportional relationships and how we can represent that in an equation. What we're looking for, boys and girls, is an equation that can be written in the form y equals k. That's the variable we use to stand for the constant value, k times x. And so what I see here are 2 equations. It says y equals x plus 6. That also means 1x plus 6. And y equals 7x. All right, there's something different about both of these. I see that this second equation, y equals 7x, is in proportional format. That is an option. But the difference is here in this first equation, we're adding some number to that variable term. And when we do that, if we were to look at this equation on a graph, it would actually shift that graph away from the origin. So it would not be proportional. So anytime you see a value that's being added or subtracted to your variable term, guys, it's not proportional. Super. All right, select the equations that show a proportional relationship between x and y. I encourage you to pause this real quick, try it on your own. But what we do see here, guys, we have both of these equations in the form y equals some number, some constant times x. In this case, 4 is our constant. In our second equation, 8 is our constant. We're not adding or subtracting any other numbers, so these are both proportional. Good luck today. I know you'll do great. Just email me if you have any questions. Bye, guys.